Welcome back everybody to the Spaceship Controller in Unity tutorial series. We are on our fourth video here. If you haven't seen the first three, I highly recommend them, as I am not going to be taking my time on this one. We are going to zip right through creating all of these scripts so that we can implement what we talked about in the last video. Starting with our weapon firing script, we're going to make a public enum like we talked about, called weapon type, for our projectile weapon and our raycast weapon. I'll make a header for this for our input. Serialized field, we're going to have two input action references, one for our fire action and one for our toggle weapon action. Then I'll make another header I'm going to call general, and I'll have a serialized weapon type called current weapon, which will initialize at projectile weapon. Then I'll make a layer mask called hit layers, and I'm going to initialize this at everything. That's what that -0 means. I'll make another header for projectile weapon. We'll start with a serialized transform for the left projectile fire point, and we'll have another one for the right projectile fire point. We'll have a simple pool for the projectile pool and another simple pool for the impact particles. Then we'll have a float for projectile fire rate, which I'll initialize at 6, and a float for projectile damage, which I'll set to 10. And projectile speed, I'll set to 60. That's going to be way too slow, just so you know. A projectile lifetime of 4. And I'll make an audio source for the projectile audio source and an audio clip array for projectile fire clips. Then I'll make a header for the raycast weapon. We're going to have a transform for raycast fire point. We're going to have a float for laser damage per second. I'm going to start that out at 20. And a float for our laser range, which I'll start out at 100. We'll have a line renderer, which I'll just call laser line renderer, and a game object called laser impact object, and a particle system reference to our laser impact particles. Then I'll make another header for our laser audio. We'll have an audio source for the looping audio and an audio source for the one-shot audio. Then we'll have two audio clips that are used for the one-shots, laser start and laser end. We'll have a private float for our next projectile fire time, a private bool for was firing laser last frame, and another private bool, fire left projectile next, which I'll start out as true. Then we'll have a public weapon type, current weapon, which is our current weapon. Then on enable, we'll have the usual shenanigans for setting up all our input actions. And likewise, on disable will be set up the way we usually do. Make sure you put stop laser effects in here just in case. And if you hear some slight groaning in the background, that is my dog chatting with me while I pet him. In our start method, we'll say if laser line renderer does not equal null, laser line renderer.enabled equals false. If laser impact object also does not equal null, laser impact object.setActive false. Then in our update method, we'll say bool is firing equals read fire input. We'll say if current weapon is our current weapon type dot projectile weapon, handle projectile weapon is firing. Stop laser if needed, else handle raycast weapon is firing. Then we'll make that private bool read fire input say if fire action is null, return false, return fire action.action.is pressed. Then we'll make our on toggle weapon performed. Input action.callback context, we'll say toggle weapon, and we'll create that method. Public void toggle weapon. If current weapon is weapon type.projectile weapon, then set our weapon type to raycast weapon, and vice versa. Then we'll say public void set weapon. Weapon type. If current weapon is weapon type, return. Current weapon equals weapon type. Stop laser effects. Then we'll make private void handle projectile weapon with a bool is firing. If is firing is false, return. If time.time is less than next projectile fire time, return. Next projectile fire time equals time.time plus 1f divided by projectile fire rate. Fire projectile. Then let's make that method. Private void fire projectile. If projectile pool is null, return. Transform selected fire point equals get next projectile fire point. If selected fire point is null, return. Then we'll make a game object called projectile object, which will equal our projectile pool.get selected fire point.position, selected fire point.rotation. If projectile object is null, return. Then we'll make a projectile, call it projectile, and make this equal to projectile object.get component projectile. If projectile does not equal null, projectile.initialize. We'll say speed is projectile speed, damage is projectile damage, lifetime is projectile lifetime, you're getting the idea here. Owner pool is the projectile pool, impact effect pool is the projectile impact effect pool. and that will initialize our projectile. Then we will play random projectile fire sound effects. Now let's make the get next projectile fire point transform. Transform selected point. If fire left projectile next, then selected point equals left projectile fire point does not equal null, question mark, left projectile fire point, right projectile fire point. Else, just do the opposite. Selected point equals right projectile fire point does not equal null, question mark, right projectile fire point, colon, left projectile fire point. Fire left projectile next equals the opposite of fire left projectile next. Then return selected point. Next, let's make that play random projectile fire SFX method. If projectile audio source is null, or projectile fire clips are null, or if anything related to this is null, return. Then we'll make an int called index, and we'll say random.range 0 projectile fire clips.length. Projectile audio source.play one shot, projectile fire clips index. Next, let's make our handle raycast weapon method, which will take a bool is firing. If is firing is false, if was firing last frame, stop laser effects. Was firing laser last frame is now false, return. If was firing last frame is false, start laser effects. Fire laser, was firing laser last frame equals true. Now let's make our fire laser method. If raycast fire point is null, return. Vector3 origin equals raycast fire point dot position. Vector3 direction equals raycast fire point dot forward. Vector3 endpoint equals origin plus direction times laser range. If physics.raycast origin, direction, out raycast hit, laser range, hit layers, query trigger dot ignore, endpoint equals hit.point. Simple health, health equals hit.collider.get component in parent simple health. If health does not equal null, float, damage this frame equals laser damage per second times time.delta time. Health.take damage, damage this frame. Update laser impact, hit.point, hit.normal. Else, disable laser impact. Update laser line, origin, endpoint. Now let's make our update laser line method, which will take vector3 start point and vector3 endpoint. This is pretty straightforward. We're just doing if a laser line renderer is null, return laser line renderer.enabled is true, laser line renderer.position count is 2, laser line renderer.set position 0, start point, laser line renderer.set position 1, endpoint. Next, let's make the update laser impact method, which will take hit point and hit normal. If laser impact object is null, return. Laser impact object.setActive true, laser impact object.transform.position equals hit point, laser impact object.transform.rotation equals quaternion.lookRotation hit normal. If laser impact particles does not equal null and laser impact particles.isPlaying is false, then we play those particles. Now let's make the disable laser impact method. If laser impact particles does not equal null and laser impact particles.isPlaying, laser impact particles.stop. If laser impact objects does not equal null, laser impact object.setActive is false. Then we'll make our start laser effects method, which will say if laser one shot audio does not equal null and laser start clip does not equal null, play that one shot. If laser loop audio source does not equal null and laser loop audio source.clip does not equal null, laser loop audio source.loop equals true, laser loop audio source.play. If laser line renderer does not equal null, laser line renderer.enabled equals true. Then we'll make our stop laser effects method. If laser loop audio source does not equal null and laser loop audio source.isPlaying, laser loop audio source.stop. If laser one shot audio source does not equal null and laser end clip does not equal null and was firing laser last frame, laser one shot audio source.play one shot laser end clip. If laser line renderer does not equal null, laser line renderer.enabled equals false. Disable laser impact, was firing last frame equals false, and we can make our last method here stop laser if needed. If was firing last frame, stop laser effects. Now let's make the projectile script. Like I said, we are blitzing through this because we already talked about how this all works in the previous video, so this should all be really clear what it's doing and what it's intended to do. We'll make our speed, damage, lifetime, spawn time, floats. We'll make our owner pool. We'll make our impact pool. We'll set initialized as a private bool. And then we'll make a public void called initialize, which will take all of these as arguments so that they can be passed in by the weapon firing script. Then in our update method, we'll say, if we're not initialized, return. And then we'll update our transform over time by our transform.forward times speed times time.delta time. If we hit our lifetime timer, we'll return this to the pool. Then we'll make the onTrigger enter method. If we're not initialized, don't do any of this. Simple health equals other.getComponent in parent simple health. If health does not equal null, health.takeDamage damage. Spawn impact effect transform.position, transform.rotation, return to pool. Private void spawn impact effect vector 3 position, quaternion rotation. If impact effect pool is null, return. Game object, impact object equals impact effect pool.get position rotation. If impact object is null, return. Pooled particle auto return, we'll call this auto return, is impact object.get component pooled particle auto return. If auto return does not equal null, auto return.play from pool impact effect pool. Then we'll make the return to pool method, which will just say initialized equals false. If owner pool does not equal null, owner pool.return game object. Otherwise, game object.setActive is false. Now let's make that simple pool script. We'll have a few serialized fields for the game object, which we'll just call prefab, an int initial size, which I'll set to 10, and a transform, which I'll call container. Then I'm going to make a private read-only queue of game objects called available objects with a new queue of game objects. And there's an error here because the using that automatically popped up was wrong. It needs to be system.collections.generic. If you run into that, just a heads up. We'll make our awake method say if container is null, container equals transform. And then we'll make a for loop here where we will create new instance. So let's create that right now. Private game object create new instance. Game object instance equals instantiate prefab container. Instance.setActive is false. Available objects.enqueue instance return the instance. Then we'll make a public game object get, which we've referenced a few times earlier, vector 3 position, quaternion rotation. If available objects.count is 0, create a new instance. Game object instance equals available objects.dequeue. Instance.transform.set position and rotation, instance.setActive true, return the instance. And then we'll make public void return instance.setActive false, instance.transform.setParent container, available objects.enqueue instance. Okay, let's make our pooled particle auto return now. We'll have a serialized field for our particle system. I'm going to call this particle system to play, a simple pool called owner pool, and a private bool called isPlaying. We'll make a public void play from pool, which will take simple pool as an argument. We'll say owner pool equals pool, isPlaying equals true. If particle system to play does not equal null, particle system to play.play true. Then we'll make our update method and say if isPlaying is false or particle system to play is null, return. If particle system to play.isAlive it's true is false, then isPlaying is false. If owner pool does not equal null, owner pool.return game object. Otherwise, game object.setActive false. Now let's implement the simple health script. We'll have a serialized field called max health. I'll set that to 50, make a private float for current health, and set the current health to the max health in the awake method. Then we'll just have a simple public void called take damage, which will take a float, which we'll call amount, and we'll basically say, as long as the amount is greater than 0, deal that as damage to us. And if dealing that damage makes our health lower than or equal to 0, die. Now that should be everything. You can go through and save all these scripts. I have a couple of errors because I accidentally put parentheses on the ends of these. So if you followed me exactly, make sure you get rid of those. That will clean up your errors. Let's go in here and make 2 empty game objects for particle pool and projectile pool. And one more 3D sphere, which I'll call test sphere, and I'll drag a health script onto that. I'm gonna scale it up to 500, and I'm gonna give it the metal red material we made earlier, just so that it's something easier to look at. And is clearly a big old target for us. Now on the Crusader, I'm going to drag on the weapon firing script, and we're going to start putting in all of these references. So I'm going to put on the left projectile launch point, the right one, and for these pools, we need to give them their simple pool scripts. And just drag them onto themselves for the containers, and we can drag those onto the weapon firing script. Now we need to actually make a projectile. Now in order for this thing to be oriented the right way, we need to rotate it, but if we do that, the forward is now going up. So let's make an empty parent on top of it. And now you can see the parent is facing the right way, and we can rotate the projectile beneath it so that it's facing the correct way, so that the forward goes along the long side of that capsule. We'll want to change the capsule collider here to be on the z-axis so that it's able to be adjusted in the right direction. And we'll add the projectile script onto here, and it's important that you add a rigid body, make it iskinematic, turn off gravity, and I'm going to set this to be continuous dynamic and make sure that isTrigger is checked to be true. I'm going to make an empty folder and call this prefabs, and drag the projectile in there as a prefab. Let's create a new material, which we'll call laser blue. I'm just going to set it to a nice blue color here, and I'm going to turn emission on and make this a bright blue as well, and just pump this up until it looks lasery. I like how that looks. I think it looks pretty good. Yeah, it's looking like a nice little laser projectile, just like that. And you'll see the capsule collider scales up with it when you scale the entire object like this. I'm going to just zero out that transform, and we'll see it's way too big. So I'm going to position it closer to the projectile point so I can see how it should look in space, and I think that looks pretty good. Not bad. Just going to apply all of those changes to our projectile and delete that. And now I can drag this prefab into our pool. Now the particle pool needs something as well. So we're going to make a particle system. I'm going to name it projectile impact particles. And I've already done this. It's a little tedious to watch someone set up particles. So you can just copy what I've got here, all of my settings. I'm showing them all very briefly. You are welcome to pause the video if you want to copy mine exactly. I would encourage you to just tinker around with particles and do it yourself, because you can get something that looks a lot better than what I made here. I just spent a couple minutes making it look somewhat like something that's exploding, but you can definitely do better. Now I'm going to create an empty game object called projectile audio, and I'm going to add an audio source component to that, turn off play on awake, add the little pew to it, and I'm going to make a laser loop audio and a laser one-shot audio. And now we can drag these audio sources, and in the projectile fire clips, I'm going to add the pew sound I made. As is tradition now at this point, I just made these sound effects by literally recording myself on my phone going pew, pew, pew. And we also need to make a line renderer component here, so we'll add that. And I'm going to make a new material by just duplicating our laser blue, and I'm going to make this one laser red. Just drag that into the material of the line renderer, drag that reference onto the weapon firing. I'm going to make another empty game object called laser impact object, and I'll make another particle system below it called laser impact particles, which again, I've already created, so you are welcome to just pause as I show you all of these various parts of the particle system if you want to copy mine, but trust me, you can make something a lot nicer with very little effort. Then for the laser loop audio, it's important that we drag and drop our looping sound effect in there and check loop. Everything else we can just drag in as references directly onto our weapon firing script. Now in our input actions, we're going to need to make a fire and toggle weapon action. And I'm going to set these bindings to things that make sense to me. So toggling the weapon will be tab and fire will be space. And I'll add some references to gamepad as well. Save that asset up and drag those references in to our weapon firing. And then make sure you drag that pooled particles auto return script onto the projectile impact particles prefab you made so that it can actually be returned to the pool that it came from. So let's hit play and see how this is all working. Okay, at least on mine, the laser beam seems to work perfectly, but the projectile particles are exploding instantaneously. That is because they are colliding with my ship. So there's two ways you could fix that. One is put the ship on its own layer and make it a layer that doesn't collide with the projectiles. For now, I'm just going to do the easy thing, which is to drag the projectile launch points forward a bit so that the collision just doesn't happen at all. And now it works, except the projectiles are way too slow. Like I said earlier, I'm going to bump this way up to 500 and try again. Significantly better. The enemy dies super fast. You can bump up their health if you want a little more time to experiment with it, but that is all working. And that's all, folks. In the next video, we're going to handle a really nice way to just simply swap between two camera modes, one for a cockpit view and one for the external behind the ship sort of view. So look forward to that. And thank you so much for watching this. If you liked these videos and you appreciate what this channel is providing, please consider subscribing both on YouTube and on Patreon. To those of you who are already doing so, I can't thank you enough for your support. I could not justify doing this without you. I will see you all next time.